If we leave something on the water surface, something will float and something will sink. Why this difference? For example, take two same size balls which are made up of different materials. One is made up of rubber and another one is made up of steel. Now, leave these two balls on the water surface. The rubber ball is floating but steel ball is sinking. When comparing the weight of both balls, steel is greater than rubber. Is weight the reason for sinking? If it is yes, then a 1,000-ton weight ship is floating on water. How is it possible? Let's see the science behind two balls. If we cut these two balls equally, inside the rubber ball, there is vacuum space. Those things have a vacuum inside and closed outside called hollow. Rubber ball molecules are occupied only on the outer surface of the ball. As a result, density of rubber ball only in the outer surface, so that density of rubber ball is very low. But steel balls don't have any vacuum space inside. A molecule of steel ball is occupied in the whole volume of the ball. As a result, the density of the steel ball is higher than the rubber ball. According to Archimedes' principle, any object fully or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object. If any object wants to float on water, the density of the object immersed in water should be equal or lesser to the density of water displaced by the object. Steel molecules are much closer to each other than rubber molecules. They are called tightly packed molecules. For example, in a room where only 10 people sit, there are 50 people seated. How would it be? The same way steel molecules are more than rubber molecules. Basically, liquid molecules have more gaps with each other than solid molecules. If a steel ball wants to float on water, it should be designed as hollow. Even if it is hollow, the total volume of molecular density should be decreased. Then, steel density will be equal or less to water density. Now, it will float while we leave it in the water. While a ship floats on water, the density of the ship submerged in water will be equal to the density of water displaced by the ship. As a result, while the ship is trying to sink in water, the upward buoyancy force will act opposite to the ship and push the ship upward. Due to buoyancy force, the ship will shake up and down while it is traveling. If loaded payload is more than the capacity of the ship, the density of the ship will be greater than water. It will lead to sinking the ship in water. If we make a rubber ball, after removing the force, it will come out of the water. Because there is no water entering the ball. If it is a hole, water will enter into the ball and increase its density. It will lead to the ball sinking in water. But once a ship sinks, it can't come out of water even after removing the payload, because water will increase the density of the ship. Ships are made up of wood, plywood, steel, aluminum, and composite. Whatever the material ship is made of, its density must be equal or less to the density of water. From this video, we have learned size, weight, and material are not a reason to float or sink any object in water. Only reason is the density of material. Thank you.